Welcome back, everyone, to the next installment of Introduction to Insect Taxonomy. This will be, I believe, part 11, where we will be talking about the Zygentoma. So, if you will remember, before we get into this, one, please like and subscribe. It does help me out. Leave comments or questions, and I will try to get back to you as soon as I check and see the notification. It always helps me out. But also, before we get into the Zygentoma, let's go over what we talked about last time very briefly. So this is the cladogram, or the phylogenetic tree of all of the orders of insects. And if we zoom in here, we already talked about the entonates, so the insectoid, insect-like creatures that aren't true insects but have many of the same characteristics. And then last time we talked about the Archaeognatha, which were the bristletails. So the Archaeognaths, if you will remember, are generally small, kind of teardrop-shaped insects with long antennae and three caudal filaments, three tail filaments. They generally have very large eyes, 6 legs, and then they also have little styli coming off all the abdominal segments. And they tend to be generally found in like rocky or leaf debris covered environments. They are generally laterally flattened. So when I say that they're laterally flattened, they're kind of squished in on the sides so that they're more arched. And this is in opposition to the Zygentoma, which tend to be more dorsoventrally flattened. So this is another picture of those Archaeognaths. They are very, very curved, and they tend to be kind of pushed in from the sides, kind of like a folded up taco. Versus when we get into the Zygentoma, they tend to be flattened like a pancake. So today we're going to be talking about the Zygentoma, which used to be part of a group with the Archaeognatha called the Thysanura, and they are very, very similar looking, although there are a few big differences. When we talk about the Zygentoma, they tend to be flattened in the other direction like a pancake. And unlike the Archaeognaths, their eyes tend to be pretty small or sometimes missing. If you will remember with the Archaeognatha, if we zoom in here, they have these giant compound eyes that are usually touching or fused together. And in the Zygentoma, the eyes tend to be onto the sides of the body, and they tend to be pretty small. There are other differences, like they don't have like all the abdominal styli, the huge abdominal styli. And when we get into some of the families, the cerci on the caudal end are reduced. The body shape is a little altered, but they still have that general body shape of kind of pear-shaped or teardrop-shaped. This isn't always true with all of the families, but that is the most common shape of them. You can definitely see how they were grouped together with the Archaeognaths into the Thysanura. So for order Zygentoma, we have really probably 5, maybe 6 families. But if you are in North America, what you are almost 100% going to be looking at are the Lepismatidae. Actually, if you are anywhere in the world, for the most part, if you are an amateur entomologist and you're just randomly collecting, you are almost certainly collecting Lepismatidae. These are the most widespread group of Zygentoma. These are the silverfish and the firebrats, which will frequently infest homes, which is where they're usually seen. And the silverfish have kind of this, kind of gleaming sort of silvery color. Some of them are extremely silver. But then there's all these other smaller groups. So why I say 5, maybe 6, just talking about this group in general. You have the Tricholipidae or the Leptotrichidae. There is some discussion, especially recently, about whether or not these are the same family. Almost all of the Lepidotrichidae are extinct. and they are known from the fossil record. There is one family, however, or one genus, Tricholipidian, which does exist. And historically, Tricholipidian was included in the Lepotrichidae. But with recent genetic information and stuff like that, we are now suspecting that it's its own family of sort of bizarre, not yet extinct, but extremely primitive and ancient insects. And so Tricholipidian is now considered maybe its own family. So if this is true, then this whole family is extinct. It's no longer around, and Tricholipidian is the proper extant family of Zygentoma. It is the only genus. The Tricholipidian is the only genus within this family. Although you can find it in North America, in which case I don't normally include extinct groups in when we're talking about these cladograms. In which case you can just ignore this Leptotrichidae. Otherwise, if that new data is incorrect, then Tricholipidian is actually part of this, and Tricholipidiidae is no longer even a valid family. So it's kind of like which one of these is true, but the genus Tricholipidian is in one of these families. So other than that, you don't have to think about these two families very much. But let me show you Tricholipidian. This is a Tricholipidian, and what makes it identifiable is, one, it has ocelli, which are simple eyes, which aren't always present, but when they aren't always present in the Zygentoma, but when they are present, they'll kind of be in the center of the head. Again, when I'm talking about all these characteristics, it would be most beneficial for you guys if you aren't already familiar with the very complex morphology of insects. To go back and watch some of my morphology videos, I do go into what all of these structures are within the morphology videos. There's a lot of morphology videos already posted, and since the majority of the morphology is already done, I am not spending a ton of time focusing on it at this point, but I will be adding to that series in the future with some of the more detailed structures and also reproductive organs, which are very useful when identifying insects. But I will try to at least briefly explain what some of these things are. So ocelli are usually present, which are simple eyes that occur in the middle of the head, not the compound eyes. There are no real scales on this body, as you can see. So most of the Zygentoma have scales, just like the Archaeonatha do. But for Tricholipidian, it doesn't have scales. It has all these fine setae. And if you remember, setae are pointed hairs that come out of a socket, and scales are broad and flat hairs, kind of like butterflies and butterfly wings. And then the other characteristic is that the tarsi are 5-segmented. So tarsi are this portion of the feet. It's the foot, the tarsomeres, and it will be 1, 2, 3, 4, 5. There will be 5 segments going out. Whereas the other Zygentoma have 3 or 4 tarsi for the most part. But you can still see the kind of tapering body shape, although it's not as severe in this as you would see in like the Lepismatidae. And if you're in North America, this species exists in North America, this Tricholipidian, this genus Tricholipidian, and the only species known in the world is Tricholipidian gertzi. I don't know if I'm saying that right. But it is from Northern California, so that's kind of cool for if you're in the U.S. So that is that one species, and then all of the other families are kind of separated. It is likely that the Nicoletidae and the Protrinimorids are closely related, and then I'm not entirely sure how the Lepismatids and the Maindroneids fall out. So I just kind of clumped them all together because I don't know what the latest cladogram looks like. Generally speaking, if you're, like I said, if you're dealing with silverfish and or a Zygentoma and you're finding them, that's probably the Lepismatids, the silverfish and the firebrats. And then if you're in North America, pretty much everything that you're going to be finding are the Lepismatids and the Nicoletids. And then, whatever this is. is also North America. But these other ones, the Maindroniids and the Protrinemorids, are a little strange. The Protrinemorids are mostly found on like various islands and jungle environments around the Pacific Rim, and there's only a handful of species. And then the Maindroniids are only found in desert environments, like extreme desert environments, like the Atacama. And then the Nicolatiids, if you are looking for them, you're mostly going to be looking for them in cave systems. So if you're not in one of those very specific environments, everything else, or if you're not in, the rocky terrain of Northern California, everything you're going to be finding is going to be a lepismatid or a silverfish. So, like I said, the tarsi of these Tricholopidian are 5-segmented, and everything else is either 3 or 4-segmented. And then there's some other differences. So for the Lepismatids and the Maindroniids, one of the things that you can tell about them immediately is they have eyes. And as far as I can tell, all of the Nicolatiids, and I think all of the Protrinemorids are blind. They have no eyes. The Protrinemorids used to be part of the Nicolatiids, and that recently got split out. But as far as I can tell, I was looking through the literature because there's not a ton of information I could find on the Protrinemorids because it's kind of a newer group. I believe they're all blind. Additionally, scales are variable. The Lepismatids always have scales, and then scales on these other ones are kind of variable. The Maindroniids that I've been able to see, there aren't a ton of good pictures that are kind of free for use or free of copyright, but you can find pictures of them on the internet. Like I said, these are desert dwelling, and they tend to not have scales, but they also tend to have a very distinctive body shape, which I will show you in just a minute. Am I missing anything else? Not really. So let's go so we can see these. So the Tricholopidian we already talked about. The Maindroniids are a little strange. So they do have eyes, but they have, and I wish I could show you a better picture of these, but they tend to be brown, and they have this very thin body shape. They don't have a strong taper like you see with the Lepismatids. They're kind of straight back. Honestly, they kind of have the same body shape as like an earwig, except for they don't have the caudal cerci that are pincers. And they tend to be brown, fairly bald, but these are desert. If you are not in the desert, you're not looking at one of these guys. They're a very small group. I think it's only a handful of species that are known in this group. There's only 4 known species in this whole group, and they're all in the desert. If you are looking at Zygentoma in your collection, or you see them in your home or whatever, you're talking about Lepisma or Lepismatids. The Lepismatids are probably what you think of when you think of silverfish. They're very silvery. This is Lepisma saccharina, so the sugar silverfish. And if you look at, they're covered in scales, and it almost looks like silvered fish scales. Very, very scaly. They have a strong tapered body, very strongly teardrop shaped or pear shaped, very well-developed caudal cerci, not as well-developed as what you see in like the bristletales, the archaeognaths, but still extremely well-developed. They have shorter, fewer segments in their tarsi, and they do still have eyes. If we zoom in here, you can see that they still have eyes. Versus like the Nicolatiids, these are the cave-dwelling specimens. There's only a handful of species, more than the desert ones, the Maindroniids, but there's not as many as the Lepismatids. But these are the cave-dwelling. You can see that they generally, especially with the underground ones, they're either in rock system, cave systems, or that you'll only be able to collect them under like heavy leaf litter. Not a ton of color. They have no eyes. They are blind. They are variously scaly and have pretty dense cetal coverage. Again, this is a different genus of those Nicolatiids. Again, you can see that they're colorless, they're eyeless. Other interesting things, which is similar for cave systems, is they are kind of missing some of they have reduced body parts. So they have smaller antennae. They have these tiny little cerci. Definitely different than when you're comparing it to like the Lepismatids, right? So this one's kind of in the middle. They still have the long cerci and long antennae, but there's a lot of genera, or I shouldn't say a lot of them, but there's a dozen different genera of this or so. and you can definitely see the difference. One of the other interesting things is also that if we go back to the what was I saying, the bristletails. The bristletails also have this sort of variability in the caudal cerci, so you do have to be careful with that. But the Tricholopidian is what I was thinking of. The Tricholopidian has these cerci that are extremely setose, so they're extremely, extremely hairy, much more cetaceous than any of these other silverfish. So like even the Zygentoma of the Lepismatids, which are have cetaceous caudal filaments, are nowhere near as hairy as this Tricholopidian. And Tricholopidian has like these extremely, extremely long cerci, which was more common when we were talking about like the jumping bristletails last time, the Archaeonace, which also have these extremely, extremely long cerci. So definitely some subtle differences between the Zygentoma and the Archaeonatha. They can be kind of annoying to learn in that they look so similar, but they're actually two different groups. But just remember that the Archaeonace are pinched in, and the Zygentoma are pinched up and down together. And that all is what I think of, and that helps me remember which way is which. And so with that, that's all I'm going to talk about for the Zygentoma. This is a relatively small group of primitive insects. Next time we're going to be getting into the alate insects, or not alate, I'm sorry, yeah, alate insects, the winged insects. So we're going to be talking about the Paleoptera. These are the ancient wings. These were the first winged insects. So we have the mayflies and the dragonflies, which I'm sure you're all super familiar with the dragonflies, but unless you live near water, you might not be super familiar with the mayflies. Both of these insects primarily develop in an aquatic state when they're in their juvenile form, and their adults are winged. So if you didn't grow up near water, you may not be super familiar with the mayflies, whereas dragonflies you can kind of find anywhere where there's a pond. And with that, I'll talk to you guys next time. Thanks.